integrates 5x to the 4 plus 1 over 2x cubed minus 4 over root x. Well, the first thing to do is put it in as x to the n. So we've got 5x to the 4, no problem. Then this is going to be a half times 1 over x cubed. It actually becomes a half x to the minus 3. Not 2x to the minus 3, but the half, because we're dividing by it there. So you might want to separate it first, half times 1 over x cubed, and then deal with the 1 over x cubed. And then we get 4. So x, root x is actually x to the half, but it's 1 over, so it's going to become x to the minus a half. Again, it's now prepared, ready to integrate. So just when you differentiate, you bring the power down, subtract the power. When you integrate, it's the opposite process. Wait 1 second. We actually increase the power by 1 and then divide by the new power, because you can see when you differentiate it back, it will revert back to x to the n. We just need a plus c in there. So increase the power for 4, it's going to be x to the 5, and then divide by the new power. Actually, it's going to cancel. It's going to be left with x to the 5. Next one, it's going to become x to the minus 2 when we increase the power. Divide by that minus 2, we're actually going to get 1 over minus 4. And the last one, increase the power, is going to make it a half, and we divide by a half, which is the same as times in by 2. So I'm going to get an 8. If you prefer to do things like it's step by step and say I'm dividing by a half, that's fine, but I'm just doing it a little bit quicker. So the final answer is x to the 5 minus a quarter. I'll leave it as x to the minus 2. You could write it as 1 over 4x squared if you wanted, and I'll leave it as x to the half. Again, you could write it as root x. Just tied up a little bit. That is our answer. Remember your plus c, because if you differentiate it back, this is an arbitrary constant. It will disappear, but we need to have that there. Part B, we're then given an indefinite integral, and we're told the answer, but we need to work out what p is. So the integral, very along similar lines, will raise the power by 1, divide by the new power. I'm going to get a third x cubed. Over here, I'm going to raise the power, so it will be x squared, divide by the new power, so we'll get half. It will be half p. And then this becomes 3x. Because if you differentiate that back, you just get rid of the x. It's the covered, it's what is the gradient of y equals 3x plus 2, for example. It's 3 using y equals mx plus c. Put the limits in, set equal to 8, and now let's substitute the limits in. So first of all, the 2, it's going to be 8 over 3 minus 2 squared is 4 times the half. That's going to be giving minus 2p plus 6. And I'm minusing the limit with minus 1 in, so we get a bit of room. So now it will be, I'll put it in a big bracket, it will be a third times minus 1 cubed, that's minus a third, then minus a half p times minus 1 squared, which is just 1, and then minus 3. That's equal to 8. Okay, I think I'll use my calculator for this next bit just to make things easier. 8 divided by 3 plus 6 gives me 26 over 3 minus 2p. And then I'm going to be adding a third, adding a half p, and adding 3. All of those ended up being negative. So add these up, plus a third, plus 3 gives me 12. And then minus 2p plus a half, that's actually going to give me minus 3 over 2p. Therefore, 3 over 2p is going to equal 4. P is going to be 8 over 3. That is our final answer.